Okay, now we will see the factors affecting the pressure in gases. A gas is a fluid, so similarly to liquids, the pressure should act in all directions as the particles are not tightly packed. In fact, they have a very weak bonding. Okay, I will take this container as an example, and this container is filled with gas particles. We know that gas particles are free to move all around in the container, and while they move, they should collide with particles, with nearby particles, or also they can collide with what? With the wall of the container. So their collision with the wall of the container shall exert a pressure. I'm gonna take this as an example. So let's zoom to this specific particle that is colliding with the wall. And as you can see, there is a slightly small surface area in contact with the pressure with the particle. And so this particle is actually exerting a force on the surface area. And since we have a force acting on a specific surface area, then we must have a pressure. And this is what causes the pressure in gases. And this pressure is actually affected by two main factors: how many collisions are happening and how much energy each collision involves. We can either increase or decrease the total pressure acting in a container by simply changing the temperature, the volume, or the concentration. Okay, in order to understand these three things, we need to know that there is something called the kinetic theory of motion of particles. And we know that particles are constantly moving, and this causes them to bump into each other. And we say that particles collide together. Okay, so the first factor affecting the collision in order to increase the pressure, because when we increase the collision, the pressure will also increase. The first one is changing the volume. Imagine having a container and then you squash the container, so you decrease the surface area. By squashing the container, what will happen is that the particles inside that were here free to move in a more surface area, particles now have less surface area to move. This will for sure increase their bumping or their collision, and hence pressure will increase as well. Second factor is temperature. Now we have the same exact container, but we increase the temperature in the second container. So now here we increase the temperature, so temperature increases, and when temperature increases, what will happen is that particles inside will have more energy to move. So again, now we are dealing with, or we're changing the motion of the particle. When particle here was moving like this, it's a moderate motion. By changing the temperature, by increasing the temperature, particles will start to move more frequently, and so the collision with each other and with the wall will increase, and therefore the pressure will increase as well. The third factor affecting the pressure or the collision and hence affecting the pressure is changing the number of particles. It's also called the concentration. So when we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 particles only in this container, when we increase the number to, I don't know, maybe 20 particles, then the chance of each particle to collide with a nearby particle or with the wall of the container increases. So here, the particle will take less time in order to collide with the particle nearby or with the wall of the container, and hence this will increase the bumping, and so the pressure will also increase. And these are the three factors affecting the pressure in a gas. Understanding gas pressure is extremely important as it helps us to determine whether it's going to rain today or not. This can be made using an apparatus called a barometer. A barometer is an apparatus that can measure the atmospheric pressure around us. So what is exactly atmospheric pressure? If you look up in the sky, and we already know how our Earth and planet is surrounded with the atmosphere, which is layers of gases, oxygen, nitrogen, and all of these gases are actually spread out to around 20 kilometers above our head. Knowing that each and every particle has a weight, Imagine how much our overall atmosphere is weighing down all on our head. In fact, the force exerted on a specific surface area for if we take all the thickness of the gases above our head is around 1 times 10 to the power of 5 Pascal. That's a huge amount of pressure acting all on our head. In this diagram, you can see how the air pressure is acting on the head of the boy. What we can notice is that as we go up, the particles become less dense. So the particles becomes less and density of the gas, unlike the liquid, can change. It can decrease or increase. And it's known that as we go up, the density of the gas decreases due to the fewer particles as we go up, because we said that the particles are spread on the 20 main kilometer of the atmosphere. And after that, the atmosphere becomes thin. And so if we take the person at sea level, at the lowest one, this one, we can see that around 20 kilometers are above the head of the boy. And so the atmospheric pressure is at the maximum pressure. It's 1 times 10 to the power of 5 Pascal. If we go slightly higher, we can see that the pressure is less, and as we go all the way to a very high altitude, we will have the least pressure. Okay? And this explains why the higher we go, the lower the atmospheric pressure. And this is exactly why when we go on top of the mountain, we know that the pressure becomes less. That's because as you go up in the altitude, going from sea level and higher, we see that we will have less particles above us, and the less particle, so the less the weight of the particle that are accumulated all together, and so the less the pressure. Okay, now this is why the jet pilots and the mountaineers on the Everest, they wear full mask breathing, because they cannot breathe on a very high altitude due to less density of the gas. And this is why our ear pop, if we go from a mountain back to sea level, or if you're on a plane and you're landing or you're taking off, and this quick change in the altitude and the pressure on your body will make your ear pop. And this is why water bottles change shape. And I'm gonna have a video explaining how and why water bottles change shape or become squashed as we go from the mountain all the way down to the sea.